Europe. Very, very early day. I think it's 8 a.m. right over there. Yeah. Thank you for joining us. We are here live at the Beyond X, and I hope everybody is keeping well and safe, sitting comfortably at their home. We have a very interesting talk today. We have with us esteemed speakers from Cobod and Autodesk. I'm TY. I'm a director in architecture studio in Singapore from Ong Ong. And I have my companion Daniels.
Yes, I'm Daniel Chandra here. I'm the director of digital technology at Ong Ong here in Singapore.
And just a quick intro, Beyond X is our annual design festival showcasing fresh technologies and speakers from all over the world. This year around, it's all over the world. Previously, we have our local speakers to inspire creativity and innovation, to share their knowledge and the current developments in the world. So today's session is Fit to Print, Building Digital Fabrication. And our first speaker is Henrik Luke Nelson. I hope I got your name correctly. He's the founder of Cobod in Denmark. And Cobod stands for construction of building on demand. Yeah. Well, Cobod is actually a leading company with 3D construction technology and 3D printing press, and is considered one of the leading experts in this field. Today, Hendrik will share with us the current developments, especially in Europe, with the 3D construction printing industry. So, and Daniels, maybe you can have the pleasure to introduce you.
Yeah, so we also have our second speaker, which is Vijay Ramadas. He's a senior research engineer at Autodesk Singapore. Vijay researches and develops solutions on flexible manufacturing and the applications of robotics, automations, and hybrid manufacturing techniques. He generates ideas and processes to enhance advanced systems for our industry. Yeah, so that's about Vijay. Okay, so just a little bit of housekeeping here. So maybe Jenong, use the next slides. Yeah, just a quick reminder for all the Zoom attendees, don't worry, your mic and cameras are disabled. If you wish to make comments, click on the chat at the bottom left. Tell us where you're from and how do you find the topic. If you want to ask questions, click on Q&A at the bottom right. Tell us which speaker you want to address your question to. If you guys are turning in via Facebook, please post your queries in the comment sections and we will try to get back to you. Audience questions will be asked at the end of the session. So that is after the first speaker did a presentation. Okay, so now let's start with the first speaker, Hendrik. So the screen is yours. You can share your screen now.
Are you seeing it?
Yes.
Yes, we can see your PowerPoint.
Yeah.
Okay. So, good afternoon. My name is Henrik Lund Nielsen. I am the general manager and founder of Cobod in Europe. And as Ty was saying, Cobod stands for Construction Building on Demand. And I'm labeling my presentation from research of state-of-the-art to becoming state-of-the-art, because our start was, in fact, that we only did research. And right now, in all modesty, we do believe that we ourselves now have become state-of-the-art within 3D construction printing. So if we look at our development, as I said, we started with 3 years research under a government grant, where together with NCC, the largest construction company, we were touring the whole world. So this was a global investigation caused by the fact that the Danish government was afraid of that we were falling behind as a nation within construction printing. Denmark is a little bit a funny nation. If we're not number 1, 2, or 3 in some industry, we get nervous. So the government was getting nervous and wanted to promote this technology, and so they tasked us together with this big construction company to tour the world, investigate all these projects, and bring home the best, bring home state of the art, to say. So that took place over 3 years. During that process, we also did 2 test printers. We tested 20 different recipes or materials for the printers, and we visited 38 different projects. I don't think anybody in the world has ever visited that many 3D construction printing projects, and I personally visited 35 of them. So I think, in all modesty, I can say I have the broadest knowledge of what goes on in the world in this industry. As a consequence, we had 2 conferences organized, and at that time they were the biggest, with 200 attendees just to hear about construction printing. And we also issued the only report that has that's ever been written about construction printing. It's 108 pages. We have been asked for many copies, and sorry, it's only available in Danish, and the Danish government will not allow us to translate it, because this was information for the Danish construction sector, not for the world construction sector, so to say. Anyway, the result of this research was, in fact, that we were actually very disappointed. It turned out that there had been so much misleading PR. And in general, we are saying, when it comes to construction printing, 95 to 98% of all the PR that has ever been issued is unfortunately not true. It is false, it's misleading, it doesn't really give the true picture. The best example I can give is there was a company in China called Qingdao, located in Qingdao, and they claimed to have the biggest construction printer in the world at that time, 12 by 12 by 12 meters. So we thought that's hugely interesting, such a huge printer at that time. So we went to visit. It turned out that the printer was just a metal structure. It didn't have a printhead, and they never put concrete to the printhead that didn't exist, and they never printed anything. But they had the framework of a printer. And I think this story really shows a lot about how the industry was, and unfortunately still is a little bit. So you've also heard, probably most of you, these stories about a 3D printed house in one day, done by, for instance, Apis Core, or done by Icon. Again, is not true. They were not done. They were done in 4 months, and so on. So on the one hand, we were extremely disappointed that the actual results were not better than they were. On the other hand, it was also clear from our analysis that it was the lack of 3D printing technology skills and competence that had caused this situation, because most of these companies and organizations were not 3D printing experts. We, on the other hand, came as being 3D printing experts. We had another company solely focused on 3D printing and so we said to ourselves, wow, there's lots of potential here. And if it was just done the right way, this could really move the construction world. So we took it upon ourselves to do the first proof of concept. So we said we're going to develop the best printer in the world, state of the art. And with this, we're going to print the first building in Europe, which we called the BOD, building on demand. And typically for us, we did it under full surveillance of the press and of people. So I'll show you a little video of what actually happened. You can see lots of press, even the mayor available, 150 spectators, and we were printing at the same time. Obviously, this was a first of a kind project, and we made many mistakes. Here's the finished building as it's standing today. We made many mistakes. It took 2 months, but we still completed it, and people were still very impressed. The journalists were saying, wow, and we were like, wow, yeah, okay. But, what can you expect? It's the same time as when you learn to ride a bike for the first time. You fell down all the time. The second time you fell down a little bit less. The third time you might have stopped falling all the time. And by the 5th time, you were actually riding the bike more than falling on the bike. And by the 10th times, you were actually riding pretty fast, and faster than you could run. And this is the same thing. Nobody masters a technology just because they do it once. Anyway, this led to extreme demand for our printer. People wanted to buy that printer. They wanted us to do projects, but we said, hang on, that printer could be done even better. You know, we found out during the first project that there were so many improvements that could be made. So we decided, no, we will hold back. We will spend even more time on developing a new printer, and we did that, which is called Bot 2. So it's the only second generation printer that is out there. So we spent about 10 months developing that. We spent 5 months developing the first printer, and now we spend 10 months or almost a year. And that because that was really, really state of the art. This is like a Mercedes 500 compared to a cheap Chinese car that the other guys are having. Then Perry, the next thing that happened was that Perry, which is the biggest manual competitor, selling formworks equipment all over the world. They have 80 subsidiaries and 20,000 employees or something like that. So they are the biggest manual competitor. And they basically said, well, we can't beat these guys, so we better join them. So by October of 2018, they joined as a minority shareholder. And that, of course, was a huge quality stamp on our organization. So by January, we then delivered out the first printer, and we delivered the next by April. And these are, in fact, 2 tenders, the only tenders that has ever been made in Europe. Because in Europe, when public organizations are buying, they have to do a tender. And we won both of them. And those were 2 educational/technical universities. Then by July, we made the biggest printer that has been made so far in the world. It is 27 meters long. It is 12 meters wide and 10 meters tall. And with that, you can build printings or print buildings with a 300 square meter floor plan, as you can see down here on the lower picture, in 3 floors. So you can actually build a 900 square meter building. So forget thinking about this technology only as small buildings and so on. In essence, we can do the building as big as you like. There's some limitations in the height and the width, but we can do them as long as you like. Let's have a look at how that printer looked like. Notice the car down in the left-hand corner. So this is heavy-duty construction equipment. You are looking at hardware weighing 16 tons here. So it's not a flimsy little toy thing. This is a heavy-duty construction machinery. Yeah, that was sold to Saudi Arabia. And then by August, we then won this iconic project by Emaar. Emaar is the Sheikh's real estate company in Dubai. And as you might know, the Sheikh has decided that 25% of all buildings in Dubai in 10 years from now will have to be 3D printed. So it's a hugely interesting market. And we won this project about building this villa, which is quite iconic, as you can see, very special design, very prestigious project. We have actually done it, but they are not making it public yet because of Corona. Then with the help of Perry, we began distributing our printers in Germany, Austria, and Switzerland. And Perry is supporting us with 150 sales guys in that market. Now I have a problem because I can't see what the next slide is saying because you guys are in the way with your, how do I move you guys away over on the right-hand side? Oh, like this, okay. So by September, we then said, hey, you know, we did the first building 2 years ago. It took 2 months. Now we've done a much better printer and we have gained much more experience. Let's do it again. Let's print the same identical copy of the same building and see how fast we are. So we did that, which is crazy also. Nobody has done that before, printing the same building twice. And typically for us also, everything is on camera, everything is on time lapse. So you can see everything we do. You can also see when we fuck up, sorry my language. Because again, you can't expect to be perfect the second time. You can expect to be better, but not perfect. And you can see there's a timer on the bottom, so you can follow how far we are coming up at what time. And again, full documentation is supplied. We had various issues also when we did that. It didn't run perfect, but we came down to 28 hours. So we went from 2 months down to 28 hours. That's like a 30 times improvement in productivity just by doing it the second time. So now what would happen if we did it a third time or fourth time? Because we're not a construction company, we are a robotics company. But you can imagine yourself the productivity increases that happens as you gain more and more experience. So if we had to do it today, we would expect that we could do it in 8 to 10 hours. Then by October, we entered into a long-term cooperation with General Electric and Lafarge. And I don't think, at least General Electric, they don't need further introduction other than to say that they're very, very large within windmills. And Lafarge is the world's biggest cement makers. So these are companies with 200,000 and 100,000 employees. And then our small little company, but we just happen to have the technology that the other guys need in order to make very tall windmills. So this is the idea of that project, that we should make on-site print very tall buildings. And we started printing the first 10-meter windmill tower last year. And we will see a video of that now. Notice what happened when we come up in the height. You don't see any people at all. You just see the printer working. So where are the guys? You know. Right. And of course, this is a long-term cooperation, so we are continuing doing lots of stuff with General Electric and Lafarge. And then this customer, the educational institution in Belgium that we supplied a printer to, they actually used it in November, but they first published it now to print a 2-story building, the first 2-story building in Europe. Let's see how that looks. This video has been downloaded 350,000 times, a testament to the extreme popularity that the technology has right now. They did one good thing. They left the printer even after they finished the building, so everybody could see that it was done on site. Very nice trick. Then by December, we had a visitor from Japan. And they were talking about a project, and they hadn't talked about that before in our previous discussion. So we said, you seem to have a project. Do you have some drawings? And they said, yeah, we have drawings. So I said, can you send them to us during the meeting, right? So they sent it during the meeting. 3.5 hours after, we were standing in the warehouse and we were looking at the first meter of their building, as you can see on these pictures here. And you can also notice the huge improvement in the smoothness of the wall quality that we have made, right? And that just shows you the extreme fast conversion from digital files to physical product that is possible with this technology. Then we started selling in the US, and we've had the first 2 printers shipped out to the US, to respectively Florida and Texas. Very well chosen. Now, when you look at where COVID is hurting the US, it's exactly those 2 states it's worst. So we haven't been able to go there ourselves yet, but the printers are there. And very unusual for a startup, we actually turned profitable already in the second year of our operation in 2019, which is quite an undertaking. Again, to prove more that how much we had improved, we showed up at an exhibition live, and we said, we're going to print a small house every day in Germany. And so we did that. It's a very small house, but still prove a point. Notice how many visitors are there looking all the time. So there's no fake here. There's no fake video editing. People are seeing live what we're doing. This is the logo of the exhibition that we are printing in the middle. They wanted to have their logo in concrete, so we printed that for them. But more interesting maybe is a more detailed shot, because these time lapse, they don't show that many details, but we can see some details here. Again, you notice when we use the flaps, the walls become very, very straight and smooth. We can't use the flaps on the lowest layers, but we can use them as soon as we come up in the height. This is again very much different than our competitors, because this is real life. You can't hide anything. So we were obviously the talk of the show, because nobody had done this before, printing 4 houses in 4 days. Then we actually also started selling printers to Africa, which was new to us. And we've also now started selling into precast plants, which is new to us. Normally we have been focused on on-site application, but now we've actually sold into the first precast plant. And in total this year, we are growing 75%, which, if you think about Corona and so on, it's not bad. And today our customers are then counting, 4 different groups. You can say large corporations, like we heard, GE, Lafarge, EMA, Perry. These are big companies. The precast plants, as I spoke about, educational institution, and then real estate developers. We have a big amount of real estate developers that wants to move into this technology and sort of shortcut some of the construction companies. Just a few words about our printer. It's modular, so you can build it in any direction that you like with these modules of 2.5 meters. So that means that you can do the size that you want. There are some limitations. It's 10 meters in the height right now and 15 meters in the width. But in the length, you can go as long as you like. So we can just see a few more details about the printer here. I think I still have 3 minutes, right? As you can see, it's extremely fast. The printer goes up to 1 meter, almost 10 tons per hour. And as a comparison, the first building we did had 20 tons of material. So that means if we put it to full speed and we could utilize that, we could print the house in 2 hours. This is showing how easy it is to change nozzles. So if you want to change the width or the height of the print, you just put on another 3D printed nozzle in 2 minutes and you're ready to go. And of course, our printers come with our own software. It comes with cameras, so that you can actually see what is going on. When you're up there, 10 meters up there, you can actually see on the screen what is going on with live cameras installed on the printhead. You can also see the parts. It's like I'm saying, this is a Mercedes 500. This is not a toy. It's IP67, so it's safe to operate outside also, even if it rains, etc. That's not a problem. You see the cameras there mounted on the printer, so that on the laptop you can follow how the print is going. And it's of course EU certified with the safety mark. So my last slide is just about the advantages that you're getting with this printer, which basically are 12 unique advantages. You can get the size you want. It's safe and EU certified. It has this fantastic speed of 1 meter per second, and you only need 2 operators to operate it. You're free to choose any concrete or mortar material you want to print with. We don't force you to print with any particular material. It has this very, very high quality, as I said. And it has this ability to have flaps and tangential control where you move the printhead in the print direction to allow for that you print very smooth walls. You can easily change the width or the height, but just by changing the nozzle. And you can either feed in material through a pump if you're doing an industrial, or you can feed it in directly at the printhead if you're testing something. And it comes with this state-of-the-art software, and it has a probe, a sensor. So even if you have an uneven surface, the printer will compensate for it so that you will still print straight, even if you start on an uneven surface. And by that, I conclude my presentation.
Thank you, Henrik. Amazing stuff. Well, design of robotic construction printers and automatic processes. I'm really quite excited. I have a few questions in mind, but I think we'll leave the questions.
Please feel free, everybody feel free to ask as many questions as you like. I'm
Yes,
here all morning if you like.
Yeah, I have some burning questions, but I think we leave the questions at the end of the session. Maybe we hand over to Vijay to start the second presentation. Vijay?
Hi, yep. So let me share my screen. Can you see my screen well?
Yes, we can.
Okay.